for your last example, let's check to make sure that you guys got the right model. So they tell you the initial value, the city population, initially 15,500, and it's been dropping by 3% per year. So the dropping, that was your key word that this was going to be what type of model? Decay. All right, so when you're writing the exponential function for decay, you have to use y equals a times 1 minus r to the power of t. And then your a value is going to be the 15,500. Your r value is going to be 0.03. Okay, so when you plug this in, y equals 15,500, 1 minus 0.03 to the t, which is going to give you 15,500, 0.97 to the t power, and then this is what we call our decay model. So then when you're graphing the function, I said you could use your graphing calculator, right, to find your table. So the 15,500, 0.97 to the x. And then do you guys remember what we did yesterday with our table? How we went by fives? Okay, now when you look ahead, it says graph the function, and then we're going to use the graph to predict when the population is going to drop below 8,000 people. So when you're deciding what to go by, take a look at the table, and you have to look and see when it's going to drop below 8,000. So look, for it's between 20 and 25 that it dips below. So you wouldn't want to go by ones because you'd have to write out 20 different values. Okay? So we can go by fives again. That's perfectly fine. So when we're graphing, we'll do 0, 5, 10, 15, 20, 25. And again, we're just going to use this exact chart. So we know my initial value, 15,500. This is 13,310, 11,430, 9,815, and I'm just rounding to the nearest whole number because on my graph, I'm not going to be plotting the 0.4s exactly, right? Because with our handmade graph, we know that there is going to be a margin of error. And I can use my same scale as last time. So it's 2.5 is every unit, or every other unit I'm going by fives. 15, 20, 25 for my x, which is my time measured in years. And then this is my population. And for the population, I have to go up to 16,000. So I think I just might go by 2,000s again, like I did last time. So 2,000, 4,000, 6,000, 8, 10, 12, 14, 16. All right, and then remember we're plotting our points. So when you plot your points, we're doing those gentle dots here. So 0, 15, 50 is going to be pretty close to 1,600. At 5, I'm at 13,310. So here's 12, so about 13,000. And then 10, I'm at about 11,000. 15, I'm under 10,000. 20, I'm about 8,000. 25, I'm at 72. Okay, and then remember, you're just connecting this with a gentle curve. when I want to find, when I want to use the graph to predict when the population drops below, just going to put a line right here at 8,000, and I'm going to find that intersection. Okay, so I know the marker is thick, but it's right on this line here. So mine looks like it's about right there if I'm using that gray line. And then you guys do have straight edges, so if you want to use that straight edge to go straight down there. Remember that, I'm going to do such a good job of the straightness there, but remember that every dash mark is 2.5 years. So this is about 22.5. So this kind of looks like it's about 21.5, somewhere between 21 and 22 years. Is that what showed up on your guys' graph? How did yours look? Was it around the 22-year mark? Okay, so that's what we would say, about 22 years. And then we can use our graphing calculator to find the exact point. We can see how good our graph is. So, do you guys remember how to find the intersection on your graphing calculator?
Yes.
Okay, so you're going to put in the 8,000, go to second calc, use the intersect feature. Well, I guess I can graph it first. Now, I already have my window set up from yesterday, so it's going to graph the first line and then the 8,000. If you need to check your window, I made mine from 0 to 30 just because it intersected really close, so I just put it out a little more. Went by 5s, 0 to 20,000, went by 2,000s there. So now I can go to second calc, use my intersect feature, and it's asking me on the first curve. What that means is, where does the first curve intersect the second one? So I just try to get on the intersection. The second curve, it's actually going to be like in that region. You can just press enter again. It's going to ask you to guess, just press enter again, and then when it says intersection, that is the precise location. Okay, so at the 8,000 mark, you get, okay, when y is 8,000, x is 21.7 years. Okay, so the exact one is when will it drop? Is after 21.7 years. And that's pretty good. Like our graph is pretty nice that it's that close to get about the 22 years. Yep. How to find the intersection again? Yes. Okay, so you're going to go to second calc. Oh, second calc. And then number 5 is intersect. So the same place you go to find your minimum or maximum, but you're just going to select number 5, and that's when it will ask you, like, where does the first curve intersect? Where does the second curve? A lot of times you don't even have to move it, and then you just give it your best guess, and it'll do the calculation for you. Okay, and make sure that you do wait till it says intersection, because if you're doing it at the guess, it's not going to be the precise location. So we made a pretty good graph there. 21.7 is very close to 22. Okay, like we said, sometimes it's harder to estimate when you get those big numbers.